My name is John Hardy, so I'm the director of the National Video Game Museum. They asked me to do a talk on archiving, and I told them that would literally take about 10 seconds, or what I know about archiving. I am certainly not the be-all and end-all. There's plenty of people who know way more than me, probably some of you. I know you do. Anybody else do archiving out here in different forms? So digital or even papers and stuff like that? So I said, let's make it a panel. We got a lot of experts up here who probably know way more than me, and I'll just do a little overview of cleaning and some procedures. And keep in mind, everybody has their own way of doing things. So certainly what I'm going to show you today is probably 10 different people would do it 10 different ways, and it's not to say one's right or one's wrong, but just the way we do it.
10 people would do it 11 different
ways. 11 different ways, exactly. Real quick, because people have asked, what do you do for paperwork? And it's real easy. That's why I said it would take me all 5 minutes to explain it. There's a company called Bags Unlimited. They sell PVC-free stuff, acid-free. So these backings that you would buy, I can show them around. Don't lick it when you're doing it. So these are acid-free backs. Again, this is archival quality. Bags Unlimited, probably other companies as well.
They do comic books with.
Yeah, right. So you want to protect everything with that.
Paper stuff. Yeah.
PVC-free bags.
Yeah.
They make them at pretty much every size and shape you could imagine, so you can get them there. The other key thing is maybe some people don't know. It's called microchamber paper. And you would put this in, so when we do like a press release or things like that at the museum, this will prevent it from yellowing over time. I mean, a lot of times it's yellowed quite a bit already, but this will prevent further decay. So depending if it's just one sheet or two, we may put a couple of sheets in with the paperwork. But again, everything, I don't want to sound like a Bags Unlimited, spokesperson, but they have pretty much all the supplies you need. And for paperwork, it's simple. You need these 3 items. You put it in, you tape it nicely, and you mark the back, whatever you want, and store it. Floppy disk. So I'm just going to cover some basics that I do a lot of Atari. I'm a big Atari 8-bit guy, so I do a lot of 8-bit floppies. And, so right away, you want to be able to clean them. So you want to get a device. Ian has one. I like his better. I might try to steal it. His is green. I got the red one. But, you basically put a floppy disk in, and you flip this over, and once you tighten it down, it allows you to spin, and then you can clean the surface of the exposed area as you go with it. So I did bring some discs, and I do have some PowerPoint. So I'm a little all over the place with this, but, dusters, fiber optic wipes. So when I'm cleaning a disc, usually I'll use one of these wipes. They're made by Rainbow. They're real. You hit them with some 99% alcohol and just clean the surface space as you're, put your finger across the wipe and hold it down, twist it, and you can pretty much clean it. Let's see what else we got. There's your alcohol. That's called a take-along. I think it's a company called Menda. It's a take-along dispenser. It's cool. You just push the top, you put your alcohol in there, and then you can just push the top. Q-tips for cleaning heads of disk drives. So it's important to keep the drive heads clean, especially if you're archiving old disks, which obviously they're all old disks today, right? And even new disks out of a box can be bad, or be delaminating or whatever, and have stuff coming off of them. So I would recommend, if you do any serious floppy disk type operations, keep the top of your drive off. When I do it on the Atari, I keep the cover off so I can constantly get at that disk. You could use, a disk cleaner that goes in like a floppy. I prefer to use the Q-tip and alcohol as well, as I'm sure most people would. There's a device. Again, we talked about just putting it on there, tightening it up. That's what it looks like, right? And as you turn the knob, there's your exposed area. Keep in mind, on a floppy, the old floppies, the side you're reading is usually, unless it's double-sided, is the side opposite the top, right? Just some samples of discs that 5 1/4s are pretty resilient as far as keeping memory of the data. So you can see this one's pretty warped at the top. And it's funny. Ian and I were talking about different things. You'll see that one on the top left there, pretty warped. But both of these discs were good and still able to be read after you take the disc out, and that becomes the issue. That's pretty disgusting. So, and that's what happens, especially if you're from, you get discs, you don't know where they came from. They could be out in the moldy, and you'll see all kinds of stuff. Obviously, this guy was a smoker, and you'll see the white where the disc is actually spinning, but the rest of it is pretty disgusting. And then this one is just totally brown when it should be nice and white, right? So you never know what you're dealing with, and of course you don't want any crap to get on the head, because if you don't clean the head, the next disc you put in there, you could be putting that onto that, right? So ruining the discs. I don't know. Well, you guys can see that. But it's meant to show like the delamination on some discs. You see the circles here that are coming up, and that's where the actual magnetic coating is starting to come off of the disc. So a lot of times you might get one shot to read a disc, and you want to make sure that everything's nice and clean before you give it that one try, right? Before that happens. That one's even worse, you can see, where you get the rings on it from the head. And all that's coming off, that's all going onto the head of the disk drive to be put onto the next disc that you put in, right? This one's really bad. This one had mold. You'll find a lot of moldy discs that you see, and you can clean them. Doesn't necessarily mean the disc is unrecoverable. In this particular case, though, the whole thing was delaminating, and you can see there's a big area there where it was completely shot, right? There's even a close up of that. Yeah, that was not recoverable. So this is a picture of a 1050 drive, my drive I use at home, and you can see the dirt on the drive. Now, you might think I was, taking some discs right there that had been, in the worst conditions. In actuality, the disc looked really good, and that's what can happen. You can get that kind of dirt even from discs that look like they might be otherwise fine. So you should always keep an eye on that. And again, I always say to keep the top off if you're capable of doing that and cleaning. There's a close-up of it, and then cleaned. Don't mind the yellowing. For some reason, that head, it works fine, but half of it's kind of like yellowed, but it's clean. And that's the Q-tip that was cleaning. So you can see all the gunk that came off on that particular pass. And the Q-tip, at the beginning, you just want to hit the head. Make sure you get it anywhere else, but just get the Q-tip a little wet with the alcohol. Nice and easy. Gently brush it off, and then take your canned air and just, dry it off so it doesn't get anything on it. And there's that applesauce, which Ian's going to talk about. But again, this is a little trickier with an Apple drive compared to an Atari 1050, in that it has that board on top, so that you kind of have to lift that up to get to the head. So it's not always just exposed. Commodore, I don't even know. I don't mess with that stuff. I don't know what it's like getting to those heads, but again, it's you can see, you want to try and keep it clean. So. And that's really all I had. That's just a quick presentation, some basics. Again, you can read up a lot online about different procedures, different ways of doing it. I'm sure AJ has a ton of different things that he does as well as these guys, and you probably all have different stuff. Again, nothing right or wrong, just being careful, being cautious, and especially when you're dealing with the old discs, is that stuff will come off. But again, I've seen some discs that well, I guess I should point out one other thing. There comes a point, and this is what I mentioned before about talking with Ian. You find a piece of software, and maybe it's not archived. You kind of have to weigh the situation, right? Can you get it clean enough just by accessing the disk at its exposed point? Or do you cut it open and take the disk out, right? Because at that point, you can take a brand new sleeve, put the disk in there, and, because you'll sometimes get a disk that's stuck, like it doesn't freely spin. So you have to figure out the weight is, am I destroying an original disc? If we were talking about like an original Ultima disc or something, the collectability, or is it the fact that it needs to be archived? So you kind of have to weigh that situation, make the best decision that you think is right, as far as preservation versus collectability, right? So, and that's really it. So thanks for your time, and I'm going to turn it over to Ian. You going next, or?
Sure.
Yeah. All right.
Hi, I'm Ian Baranowski, and I'm going to talk about Applesauce. So I'm non-technical. There are people in the audience and at large that know way more than me about disk drives, disk technology, reading disks, but I am an archivist and a collector. I don't sell the Applesauce, but I want to support the developer, whose name is John Keone Morris. And I am biased towards Apple II, and the system is biased towards Apple II, but that doesn't mean it doesn't read a lot. It reads a lot of systems. So, why would you want a flux image? This Applesauce system is a flux imaging system. And, you want to capture all the data on the disk, including hidden files and copy protection. In the Apple II world, there's some software that is utterly irrelevant, educational software that doesn't do anything special, but the copy protection is unique and novel and way more interesting than the actual program data. So sometimes for us in the Apple II world, copy protection is an endless source of fascination and amusement. And then, we're still discovering new software versions. It's surprising how many versions of, games in particular that these companies released. And, we'll come up, suddenly we've discovered there's a Wizardry 2.1. We didn't know that there was a version 2.1. And, in the random, 10 Wizardry discs I've imaged, suddenly there's something special or new. There's dozens of versions of Infocom games. It's kind of fun to discover. And then it's up to, other historians to look at the data and determine what was changed. Sometimes it's 1 byte, but it's still fun. And then we also don't know what possible future uses there'll be for these flux images. And just to say, if you don't understand what a flux image is, it's an image that, a disk image that captures all of the fluxes on the magnetic storage medium. And that fluxes are the way that the data is stored. It's not necessarily the way the data is interpreted. So I'm not going to be the best guy to totally explain what it is, but it's the most basic analog information we can gather from the disk, because these disks are analog to digital technology. So to get started, if you want to do flux imaging, you'll need an imaging solution, which we've used, between us have used several different kinds. And you'll need a pipeline not just to read the disk, because as John has shown you, they can be dirty and messy and damaged. You'll also want to analyze the flux image for errors. You'll want to attempt to recognize copy protection if you're reading original disks or commercial disks. You'll want to convert the flux image to a supported disk format, something that is useful in an emulator or a simulator or on real hardware. And it's nice to get final confirmation of the disk image by using emulation, dropping that disk image into your emulator and it running. Most of the time, if it boots up, it's going to be a good image, but sometimes you can run it longer and find out it has other problems. But for the most part, a pipeline is what you want. It's nice to just do all the rips, but it's way more useful to know you have good information in that file. So I use the Applesauce floppy disk controller. You can go to the applesaucefdc.com. There's a lot of information there, and a lot of information from this talk is from there. It's created, the device is this little box here, and it was created and it's maintained by John Keone Morris, a developer who lives in Hawaii. It was released in 2018, and there's 2 components to this Applesauce process. There's the box, which is a floppy disk controller, and there's a client, which any of you can download if you use Mac OS or VirtualBox. And it's free and it's full of functionality. It's very fun to look through flux images if you're, lame like me. So they've sold about 1,000 units. There's a third version of the hardware design coming soon, as best I know. It has a few minor improvements, and mainly for people like me, I have 4 or 5 drives ready to be hooked up to the thing at any given time. It's going to allow for multiple drives to be hooked up to the device and to switch between them. So it won't give power to all the drives at once. It'll pick which one you want, which is convenient for me, because every time I get a pile of disks, they get imaged. And the client development is ongoing. There's updates weekly, every 2 weeks, or sometimes every month, depending on how busy John is. There's an active community around this in a Discord community that anyone can join, see what's going on. And there's constantly people saying, John, here's a new novel format. Can you support it? So it's an expensive system. The floppy disk controller is $285. And I think it's worth every cent if you plan to image a significant amount of disks. Like me, you have, I'd rather spend the money and save the time. And I'm really quite averse to command line interfaces. You also you usually want to buy a sync sensor if you're going to do protected disks, which is cheap and pretty easy to install, although John didn't want to install one, but I bet you it's within his capabilities. It's pretty easy. You kind of stick a little magnet in there and this little teeny board. If you want to do PC drives, you get a cable kit. It's $15. I have one here. And if you want to pull an Apple 3.5-inch drive, they're usually Sony drives, out of a Mac and connect it, you can use this connecting cable, which I don't use. I just took another Apple 3.5 case and put a super drive that I extracted from a faulty Mac 2SI. The 2SI and the 2CI both have a super drive, which is a great drive that reads anything from 400K disks to 1.44 megabyte disks. So that's the optimal way to go, but you can just use your 720K, if I have that right, drive. There are other flux imaging solutions. They're all cheaper as best I can tell, although I've never priced one out from A to Z. The Grease Weasel is $30, and these are just prices I just looked up. That's a pretty reasonable solution. SuperCard Pro I saw for 100 cryoflux is 125, 175. These are all proven solutions. I never saw a price on a flux engine. You probably have to do some cabling and figure out the power. There's probably a few bucks more. I would say John's solution, it comes with a power supply. It's a reliable power supply. Don't use an Amazon power supply with it. It's spec'd to the way he wants it. If you don't spec these things right, you may find, they can be finicky. So you can use the client without the floppy disk controller. It's mainly the disk organizer. The disk analyzer, which is this upper image. And when you get a flux image, this is what pops up after you save it in the Applesauce client. All the green dashes are validated tracks and sectors. The graphic representation I find incredibly sexy, and then there's the actual nibble data above. If we have time, I'll click on some of the functionalities. I think it's all so fun. With the floppy disk controller, this box that costs $285. You can also fast image disks, flux image disks. You can write disks, which is always useful if you are bringing in new computers. You just have to find the images online to write them. You also have to have good floppy disk, which is not hard. Just used is fine. It also does disk drive diagnostics, and it also has an analog test, which is very Apple II centric. But I think the analog test works for other PC drives and stuff. So Fast Imager, just to kind of give you an idea, can capture an unprotected C64 disk in 14 seconds, an 800K Mac disk in 33 seconds, an Amiga disk in 27 seconds, a 1.44 PC disk in 48 seconds, or an Apple II disk in 19 seconds. And so it's a good way to archive data disks, non-protected disks, and it minimizes contact with the disk and reduces heating. And it also gives you the opportunity to make multiple reattempts on a disk if you have bad sectors. And frequently you can do that alone. And if you keep having trouble, take the disk out. It allows you to clean the heads, put the disk back in. You could clean the disk, put the disk back in. You can keep retrying in between on the same image. So it's pretty convenient. Disk analyzer, it determines the encoding method, and some of you may know there's 3 primary encoding methods for floppy disk: GCR, which is group coded recording, I believe. Group code. FM and MFM, which is frequency modulation, and I'm forgetting what the M is. Modified frequency modulation. GCR is Apple II, and I believe it's actually Macintosh and 2GS, and Commodore 64. FM is old stuff, but is it Atari? And MFM is PC. So the disk analyzer, which I showed up here, up above, also, and actually the fast imager also attempts to parse an image for a known file system. So it'll tell you if it sees a Commodore file system or an Apple file system. It can be pretty useful. It detects known protection methods. That's actually in flux imaging. And it validates the consistency of the flux data. And it converts the flux image to a disk image that you can use in emulation or simulation. So this is a busy slide that is kind of a table. I'll go through. I'm not going to really talk about too much, but it shows the many formats and the many file formats that it can, image formats that it can export to. And it can also, if you note up top, this is all what the disk analyzer can do. It can import CryoFlux, SuperCard Pro, as well as disk ferret images. And so if you don't even have this device and you're using one of those other devices, you can use the Applesauce client to do some analysis on your images. So that's going to be useful to everybody who has access to Mac OS. And then this is Atari 8-bit, ST, Commodore 64, 1541, which is, everything that used that. Amiga, Heath Zenith, PC, Northstar, TI, TRS-80, Victor 9000, which was apparently totally crazy. And this is a little out of date because it does do a lot of 8-inch CPM formats, as some of you know. What I love about it, it's a Swiss Army knife for disk drives. You can test and diagnose drives. I've definitely done a bunch of disk 2 repairs using it. You can read disks, write disks, adjust the speed. Applesauce has a graphical interface, which is more popular. There's other clients for some of the other flux imaging solutions that have a GUI, but it was kind of the first that had a really sweet GUI. It's auto-magical. I don't really need to know anything about the disks. I'm non-technical. I don't know how many tracks. I can look it up, but I don't want to. This figures it out. It's elegant, and I think it's the best Apple II solution. And it absolutely is. I can say with confidence if you're going to do protected disks. The disadvantage is expensive. You can get other solutions for less. It requires Mac OS, which you can run virtually. It's currently unavailable, but John says it's going to come out soon. I hope he has time. It probably will. It's a solo developer who's very responsive to the community. Those of the people who are on the Discord know he's generally very responsive and excited about implementing new file systems. And some non-Apple protected disks may require Apple drives. There's a slightly complex caveat to reading protected.
Things like that. Yeah.
To what?
Like quarter track, you need a real drive.
Well, I mean,
Extras.
I was really referring to 40 track reads. If you want to do C64 and Atari 8-bit protected disks, like commercial game disks.
Non-Apple systems.
If you the Disk 2 drive, which is what you're referring to, only does 36 tracks. These other, including TRS-80, do 40 tracks. If you want to do 40 track Atari 8-bit, C64, TRS-80, or other disks, then you have to get a 40 track Apple II drive, which is generally a third party drive. And they're not terrifically expensive. It's like $50, but it's a bit of a finicky process that you might need a little support on getting the right drive. And I'm honestly still working on that. So I'm just about done here. Something to never forget is, although it's sweet to clean those 5 1/4 inch heads directly with a Q-tip, never clean at least an Apple 3.5, but probably a PC 3.5 disk directly with a Q-tip. it forces you to lift the head, which has a spring, and you might bend the spring so it won't apply the appropriate amount of pressure. It's always best to use a cleaning disc for your 3.5-inch drives. It's a good way to mess up your 3.5-inch drive. So you can just run those cleaning discs and you're good. The other thing I'd say is if you get an Applesauce, always unplug the USB to power it down before you swap drives, because it will damage the drive to swap drives while it's powered on. It has two power supplies, a 12 volt and a USB, but always unplug that USB. I've definitely wrecked an Applesauce by not unplugging it. So copy protection methods are arcane and varied, and your choice of archival solution will be based on your primary platforms and your archival goals. So thank you very much. And now I think we'll hear a bit about Grease Weasel. I'm excited.
All right. Hello, everyone. I'm Gene Toy. I'm just a local member of the retro community here in DFW. I've worked a little bit with John on some mystery discs he had, and that brought us to discussing the Grease Weasel. So somehow I've become the expert. So I'm going to give some introductory information. So the Grease Weasel. The Grease Weasel is an open source USB device, and this is basically a quote from his website, reading and writing raw data on nearly any type of floppy disk. So this is yet another flux reading device. So similar to what we just heard about the Applesauce solution, this is reading at the magnetic flux level, creating some of the same sort of files like the .scp file. It's kind of its default. So a fellow named Keir Fraser in the UK developed this. He is quite the disk guru, so even if you've never heard of him, people who have GoTech drives with flash floppy, I'm sure there must be a few out there. All right, he wrote flash floppy. So this is a man who does know his disk drives. He's got a GitHub where you can find the Grease Weasel plus flash floppy, and he has a variety of tools for analyzing disks, converting formats, things of that nature. There's also a Grease Weasel Facebook page. It's a very active group. People there are very friendly, very helpful. So if you're getting into it new and you need a little help, it's a great place to go. So, hardware. So, as I said, it is an open source solution. Keir has developed several different boards, and some third-party people have taken his designs and created a few other variants. They are open source. You can go download the Gerbers, the firmware, build one yourself if you want. There's also a variety of sellers on eBay and such not, including Keir himself. And if you go to the GitHub, the wiki has a page of sellers he maintains. So you can build it, you can buy it. I'm going to talk about two of the boards specifically as they're the ones I've used. The F1 and the F7. Let's start with the F1. So this is an F1 Grease Weasel. You can build it yourself. You don't really even need a PCB if you want to hand wire one. It is basically using what's commonly called to as a blue pill STM32 microcontroller board. They're available inexpensively, and it is directly driving the standard 34-pin floppy bus from the microcontroller. So it's a cheap solution. You can only connect one drive at a time. Couple small caveats. As I said, only a single drive. There are some issues with some older drives that have higher pull-up values on the termination resistors. And again, we're directly driving the floppy bus from the microcontroller and it can't quite drive it. But more modern drives are not an issue. And be sure to read the discussion about counterfeit boards, the blue pills. There are counterfeit STM32 microcontrollers from China. Some of the counterfeits still work just fine. Some of them don't. He has a simple test program that you can load onto one, check for the blinking LED that'll tell you if it's good to go, or if best, try to find one that's authentic, but you know, that can be pretty tricky when you're buying from places like Amazon. And I did start with this. I actually hardwired one myself first, and then I got the PCB. And so I worked with one of these for a while. I have upgraded to the F7 board, and it's installed in this cabinet here. The F7 can support 4 floppies at once. So in addition to the microcontroller, it has all the appropriate buffer logic and drive selection logic to deal with 4 drives at once. You use the drive select jumper. So you can see in this cabinet I have 3 drives, 2 5 1/4, 1 3 1/2, and that pretty much covers the standard world of those 2 size media. And through the command line tools or the GUI tools, I can select which of those drives I need to flux from. And so that's mostly, as an aside, a computer reset build. It's an old SCSI drive cabinet that I've repurposed. I think all the drives might be computer reset drives for certain. The middle drive, the black one, is a PC Junior drive. So, software. So his default software is Python based, it's command line driven. So the out of the box solution is not necessarily the friendliest if you're not a command line kind of guy or gal. But there's a very popular third-party tool. It's not written by Kier, it's a third-party guy, but he keeps it up to date, called Flux My Fluffy Floppy. And it is basically a command line overlay that will let you use a GUI to select appropriate options, and then it will drive the Grease Weasel as you have configured. Other tools, once you have an image, there are various tools. I like the HXC floppy emulator, particularly when you're dealing with things that are FM, MFM formatting, although it does understand Apple II and Commodore 64 formats. It's useful for converting to different formats for emulators. It's also useful, similar to what we saw with Applesauce. You can get a disk image visualization, see which sectors are good, which sectors are bad, and look at the data from the flux interpretation. So that's one of my particular favorites. What about if I have a 64 or something? So at the flux level, magnetic pulses are magnetic pulses. It's really about your software tools. His command line has been adding more of the kind of, I'll call, non-FM, MFM formats. So it does understand those things. I'll remind you, if you have a 1581 drive, it's already MFM format to begin with because that's how they work. And so you can use the standard tools with really no consideration to duplicate, read, and write the 1581 floppies. What about flippy disks? So flippy disks are an interesting challenge. Even though certain systems, say the 1541 drive, never really cared about the index hole, so it was very easy to get your popular notcher, flip it, use both sides, save a little money. The Grease Weasel does use the index hole for synchronizing its track reads. And so that means if you have a flippy C64 disc from days gone by, you can't readily read the back. Now, if you're super careful and super skilled, you could punch an extra set of index holes into it and flip it. I'm going to mention there is also a tool specifically for imaging Commodore discs that works with Grease Weasel called DDR64. I have used it a little bit, but I don't notice that it's been updated lately. So I'm a little concerned about that. It had certain special support that if you had one of, I think there were 2 specific disk drive models that you could do specific surgery on, and they could actually read a flippy disk both sides at the same time. And his software would handle that. But I don't know really the state of that tool. I've never found either of those drives to make the particular modification on. So, just as a caveat, flippy disks can be a bit of a challenge on the Grease Weasel simply because it is sensitive to the index hole. What kind of other drives could you do with it? Well, with an adapter board, you can hook up 3-inch drives like I think the Amstrads used. Again, with a similar sort of adapter board, you could image 8-inch floppies with it. So, that's the end. So I haven't talked about cost. So since there are a variety of venues, your cost is really going to be based on what you want to build. Your minimum needs are a Grease Weasel board of some sort, at least one disk drive of the type you need to image, and the appropriate power supply for that disk drive. The Grease Weasel itself is a 5-volt device, so that's easily powered from, a normal AT supply like in this case. So if you start with one of these solutions, you already have a floppy drive handy. You can build this for probably $15 or something. An F7 board will cost you more like, say, we'll call it roundly $40. And then plus you need to add the extra things. Software, I use an old Windows laptop that was my daughter's school laptop from a few years back. So no special needs there. So I think that's a good introduction. So I will hand it over, and we'll hear some more stories about oscillators.
I don't have a PowerPoint. Adrian is my name. Adrian's Digital Basement. Some of you may know me. I'm coming at this from I got an old computer. I need to use this thing. How do I make a disk for this side of the camp? That need is what got me introduced to floppy archiving and the reverse, which I think John alluded to. What's great about these tools is they allow you to make real disks from stuff you can download over the internet. So perfect example, you find yourself some cool computer here on one of the tables, you get it home and you're like, oh, well, this is like an Apple II. How do I make an Apple II disk? Well, yeah, there are emulators out there, floppy emu, stuff like that.
You can use ADT Pro.
ADT Pro with a serial connection, that's right. But if you have a machine that has no serial card, you just have a floppy drive and a computer.
Or you can do it over the audio interface.
Okay, well, there's different with an Apple II, but insert like magical computer that has some weird, disk format. What's cool about these solutions, all of them, but I personally use Grease Weasel for reasons I'll talk about in a second. You can, find an original floppy drive, Doesn't have to be an Apple II drive. If you're trying to make an Apple II disk or Commodore disk, you find a PC floppy drive, and you can just make actual disk images that you can take out, stick in your machine, and boot your computer. Now, for me, part of the nostalgia of these old computers is using the original disk formats. You know, the noise, the bad sectors, the like, oh, cursed thing, all that kind of stuff. So I love the actual experience of using disks. As much as they suck, because they're all failing, as John was talking about, like the magnetic material shedding off on your heads and stuff. So I do love these tools. And now let me talk about a few other things that if you're going to try to do this, that you need to keep in mind that hasn't been talked about. Does someone have a disk here that's... Oh, here we go. So, oh, look. Same as my shirt. Yeah, I wore this today on purpose. I knew I'd be up on stage. So the thing about these discs you have to keep in mind, this is just a circular piece of magnetic, spinning rust, like a hard drive, right? There are physical differences. Well, okay, so when you look at this disc, you can't know exactly like how the data is written onto this. What drive was used to make this disc? And the reason why that matters is because this is like a blank slate. It doesn't, the whole concept of tracks, 40 tracks, 80 tracks, 36, 37, whatever, that is arbitrary, and it's created by the drive itself. There's an Apple II floppy drive here. It might be, 37 tracks, and a PC uses 40. And the flippy thing that Gene was talking about is where you would actually notch your disk like this one is, and flip it over in the disk drive. And that stuff matters if you're trying to archive a disk, but also create a new one from a disk image you've downloaded. And that's because different drives, different physical floppy drives have physical characteristics about the way they write to the disk. And I don't mean like the magnetic signal necessarily, but the track spacing. So this is probably an Apple II disk drive, I take it. Yeah, or Apple II disk. So it's a 48 track per inch disk. And that means the physical stepper in the original drive steps the read-write heads 48 tracks per inch, right? The spacing of the magnetic circles that are written down, the magnetic flux information that's put on the disk is at that measurement, so to speak. High-density disk drives on PCs, those 1.2 meg drives, that was IBM's. What IBM did is they took the 8-inch disk drive and they shrunk it down to make the 8-inch disk format on a 5.25-inch disk, but they completely messed it up because the problem with these disks specifically is you can't tell by looking at it what it is. Is it high density? Is it not? How many tracks were written on here? How many tracks per inch were written on here? There are a lot of variables, unfortunately, that are written onto this blank slate here that you can't just tell by looking at it. So one of the things I've run into when I'm trying to like make an old computer work and I find someone's archived a disk image is they used the wrong disk drive to make the original disk image, the flux image that I can then download off the internet. They maybe read this 48 track per inch disk with a high density PC floppy drive, which are one of the most common ones around. They were in all like PCs until disk drives went away. The issue is those run at 360 RPM, but these disks were written at 300 RPM. And Atari disks are written at 280 RPM. Unfortunately, those different characteristics matter. So if you're trying to do disk archival to preserve stuff, you really need to have a drive that is the same physical characteristics as the original drive that created the floppy. Meaning, don't use a 96 track per inch drive to flux image a 48 track per inch disk. It can work, but it makes the recovery onto a real disk later much more difficult because the floppy images run at the wrong speed and there's extra tracks that are blank because it maybe read all 80 tracks when there's only 40 on here. But to make it even worse is some drives are 100 track per inch. I was talking to AJ about this morning. And if you try to read a disk like this disk or a 96 track per inch drive or a disk on a drive I'm getting confused here. If you try to read a 100 track per inch disk that looks just like this on a 96 track per inch drive, it's going to kind of work. You'll get some tracks that will read, and then it's going to get all out of sync, and you'll get a bunch of messed up reads. So you actually need three types of 5.25 inch disks drives: a 48 track per inch drive, a 96 track per inch drive, which is 80 tracks, and a 100 track per inch drive. And that actually covers all of your 5¼ inch needs.
Including the Apple II?
Yeah, the Apple II is a 48 track per inch mechanism. I don't see who asked that question. Oh, AJ did, yeah. 48 track per inch. Even though the encoding is GCR, the Grease Weasel, as an example, because it's a flexible tool, can read GCR disk images without any trouble. Even with a PC floppy drive, you can read an Apple II disk drive. Now, the flippy thing, which Gene alluded to, these have these index holes right here that most Sugart type interface drives, which like PCs and Unix machines and CPM and all that stuff does use, means when you flip the disk over, obviously the sensor can't read this hole anymore when it's flipped this way. But Apple II's, Commodores, and Atari doesn't use this. So that's why you're able to flip the disk over for double-sided. What they have as well, Gene, I don't know if you knew about this, you can replace, so the index sensor, if everyone's not familiar, it's literally like an LED on one side of the disk and a photo sensor on the other side, and it shines a light through there. So as the disk is rotating, it's able to like read that signal, so the capture device or your disk controller in your computer knows exactly how fast the drive is running, so it's like a synchronization signal. What I did on one of my drives is I bought a little optical sensor, and I flipped the floppy drive over, and I just stuck it on the bottom, and then I put a little piece of shiny metal tape on the spindle part, the part that spins on your drive, and I just wired in what used to be reading this hole to that new sensor. So it doesn't matter if I flip the disk over, it doesn't use that hole anymore, it's using the spinning spindle. And the Grease Weasel only needs to know the RPM, 298.6 or whatever it is, to synchronize. I'll be making a video about that, plus a bunch of other Grease Weasel stuff. It's annoying to use the command line stuff. So I wrote a bunch of scripts. So when I have a disk image I need to create onto a real disk, I just drag the image onto a batch file, and I'm using Windows, but of course you could run this on Linux or Mac or whatever, and then it just makes the disk. It says, please insert a disk, press enter, and then creates it. So I'll put those up online when I get that video ready. But it takes a lot of the guesswork out of using the tools that are command line. They're kind of not well documented. But I digress. That sensor thing is just a great way to read the flippy disk. Now, I think some of you might be wondering, why can't you read both sides of this disk in a double-sided disk drive? Like PCs, right? They have two read-write heads on them. So why can't you just stick it in there and read both sides all at once? Well, that's because when they add the second head, they offset the way it reads and writes from the second side. Yeah, AJ has a thing, it's like this. So when you flip this over in like a single-sided disk drive, it's reading and writing in the exact same spot on both sides. The flippy modification, the Gene mentioned, you actually physically remove some material from your floppy drive, and the heads can like move beyond where they're supposed to go. And that's that flippy mod. But I don't bother with that, because if you add the new optical sensor for the index hole, you can just flip the disk over in a regular PC floppy drive.
The other is it's spinning the other way, but if you're imaging the flux.
Yeah, so the other thing that can happen is, obviously, when you flip it over, the disk spins backwards. So if you're trying to read both sides at the same time, but that's easy. You can, if you're able to read the opposite side while it's spinning the wrong way, you just can reverse it in software. So with Grease Weasel, there's another piece of software that was written by a separate entity called Flux Engine that uses the hardware. They have their own hardware, but they're able to use the Grease Weasel hardware. And Flux Engine supports, it's a GUI interface as well, and command line both. Supports a bunch of other formats as well. So it allows you to use, again, a PC 360K floppy drive to read and write Apple II disks, Atari disks. It's great. So for the price of a $40 Grease Weasel, Linux, Mac, and Windows compatibility, and then a whatever 360K floppy drive, you can find one. You can make a lot of the disks for all your old retro computers. And I've been able to find stuff that people were gracious enough to have archived, and then upload to archive.org for floppies that were like for long lost systems, like my Southwest Technical Products Corporation PC 6800. There was like this version of this OS this one company made, and someone archived it. They did use the wrong drive. They used a 96 track per inch drive, so it was running at the wrong RPM, and so it was a bit of a nightmare to make a disk from that. I actually got the original hardware booting off the original OS, and it was like, I felt very triumphant. I was so grateful for the person who took the time and effort to archive that disk. So because of that success I've had doing that, it's really important for me that anytime I find stuff that I think is not out there, that I'm going to make a disk image of it myself and make sure to put it on archive.org where everyone can upload it. And I took a few notes here since I didn't prepare for this. One other thing I wanted to say as well is if you are archiving stuff and you're going to share it with the community, because that's the good thing to do, right? Please use a format when you upload it that anyone can use. And case in point is unfortunately like the Applesauce can save all these formats, but it also has a proprietary format that only you can use with its software. And I found stuff before that I've downloaded and I'm like, it's in the wrong format, and I have to get my Mac out and load it up just to convert it to a format I can write with my Weasel, because I don't have a Applesauce. And if that's not around in the future, or Mac OS is updated and the software's not, and you can't run it, yeah, there's a lot of those types of issues. That's why I'm a big proponent of open standards. So just if you save it in the Applesauce format, that's fine, but also save it in like IDF or one of the other commonly available formats.
Do you have a preference?
I do not have a preference. Gene alluded to the tool, the HXC tool, which is designed for this floppy emulator that originally came out before the GoTech and Flash Floppy did. That tool is available to run on any platform as well. It's written in Java, so it's cross-platform compatible, and it's very functional at like loading disk images and exporting them as other formats. In fact, part of the scripts I wrote for the Weasel involve using that tool in a command line basis, because it's a GUI program, but it has command line as well to automatically convert stuff. Specifically, Atari disks are very difficult to write on the Weasel specifically. So you download like a normal ATR file, which is what you would use on like a FujiNet to boot your Atari. If you're going to try to make an actual Atari floppy, I have to use the HXC tool first to convert it, and then write it out with a format that I think I use Flux Engine to write that on Weasel. But point being is that there are a bunch of different formats, and I don't know. AJ over here does a ton of this archiving stuff for people. In fact, if we'd had this sooner in the VCF experience, I would say, hey, if you have disks at home you think need to be archived, bring them. And AJ would do it. He has a booth in the main hall.
I was already overwhelmed this weekend.
He was overwhelmed with people. But yeah, he's got a setup with a bunch of drives, and he has an Applesauce over there and stuff. And so it's so important to get these disks archived. And if you've seen this Plexus P20 thing I've been working on, this Unix computer that sort of lost to time. The hard drive was the main way this thing worked, but it does support a floppy drive. And I have now created a floppy drive on that machine. And then, of course, I've flux imaged it. So I made a recovery disk. So if anyone ever finds one of these machines again with a bad hard drive, you can now boot it off of, or run commands from the boot ROM off a floppy disk that you could write with a Weasel. It's just an MFM style disk. So it's not a crazy format, but it is 8 sectors per track. It's a little bit different than normal. Then you can format a new hard drive and stuff with it. Like the tools are on this floppy disk image I created. So, yeah, we're probably out of time. So I guess questions? Yeah.
The topic of the tracks per inch.
Yeah.
If you're using the 92 or 100.
96, 48.
How quickly would you, or at what point would you realize that you had made an error? If you're following the pipeline concept, would you encounter it after you, when you test the emulated image, or when you go to write it?
Well, you'll get read errors because most of the flux, it depends, because the flux imagers, as you're reading a flux image, you can kind of see if it's reading properly, and it starts to read, and then it starts to get out of sync, and you just get tracks that completely read wrong. And then you end up at a point where you're reading track 40, and you're actually, the physical heads, it thinks it's reading 40, but the heads are reading track 42. Or the other way around. I can't remember which way it is. It kind of gets out of sync and then starts reading the wrong track. So you'll see that. You guys have microphones too, so if you want to chime in here. So yeah, it's unfortunately difficult because I mentioned you can't look at the disk and know. And if this is a system that's unknown, you kind of have to do research to see what was the physical disk format. Commodore 8050 drives for the PET, 100 track per inch. I have a word processor, this Z80 word processor, 100 track per inch. Oh, and there's hard sector and soft sector. That's a whole nother can of worms.
A simple test I use a lot of times, especially if I think I know what something is, I do the flux that I think works. I fire up HXC, and you hit the load, and it's got a progress bar. And if the progress bar is smooth and pretty quick, you know it's not having any troubles interpreting this flux data. But if it's really slow or it stutters, you know you either had a disk with bad sections or you guessed wrong about it. And that's often just a really quick visual test for me.
I want to show that this visualization. Yeah, like the visualization you get in HXC and the Applesauce utility, it shows this actual sector map of the disk is really good as well to see. Like when you load your flux image, you'll know very quickly when it's out of sync because you get all this like red and it's all like messed up, and then you have to go, okay, well maybe it was written on a 100 track per inch drive. Unfortunately, the systems that use 100 track per inch it's definitely rare. But like I said, the Commodore PET 8050 drives and a few other like esoteric old like late 70s systems, Micropolis kind of came up with a 100 track per inch format. And Tandon, who made tons of disk drives, including the ones for the IBM PC, they made 100 track per inch drives. And when you flip them over, the TM100 or what's the Tandon models? Okay, whatever. There's a bunch of Tandon models like Dash 4 is a 100 track variant. And like when you look on eBay for the drives, there's the visualization. Well, that's like really high res visualizations. So what happened in that one?
This is a copy of Karateka. You can see the outer tracks kind of have a conventional. They just look like there's like a track division, and then these inner tracks are just all kind of a smudge, and that has to do with the copy protection. But here's damage to the disk that you can visualize just going from edge to edge. I mean, I tried this disk a dozen times. I cleaned it. I mean, it's preserved, but it's one of these things like when you see something on the visualization, it's always kind of fun.
Yes.
Yeah.
Who knew on that game if you flip it over on the Apple II, the game runs upside down? Yeah. I only learned that like somewhat recently, and I played that when I was a kid, but mine was a pirated copy, so it didn't have the backside of the disc. But yeah, like the visualizations you get are very helpful for figuring out if like something has gone critically wrong. But it is a difficult problem because you have damaged disks, you have copy protected disks, you have all sorts of faults. You could have a fault with your drive, with the heads. You could have a mismatched format. I mean, it's unfortunately there's no like one easy solution to actually making these images. And that's why you almost have to build yourself a little arsenal of different disk drives. You're going to be serious about this, but if you're focusing on one type of system, like you're an Atari person, you end up with a lot of Atari disks. You just need to make sure you have a solution that can just read those. But AJ has to deal with like many different random disks that come up to you. Oh, and there's another crazy caveat: the 8-inch disks, because there's double-sided versions and single-sided versions, and the index hole's in a different position, and there's write protective versus not, and the notches and stuff. So it's all over the place. But needless to say, it's a super important thing to do because, like I mentioned, I've had hardware that I've gotten and tried to get working, and if it wasn't for images that someone had made at some point randomly in the past, who found a disk from a estate sale and thought, I'll stick this on archive.org, but they didn't have the hardware, that literally enabled me to get the machine running again and like show this piece of history that someone worked hard on to make work at some point in the past. I could make it actually run the operating system and show off what that machine was supposed to do when when someone was actually using it for its intended purpose.
I have a similar but slightly different version of that story. So I grew up with Commodore in my college years. Played a lot of Mule. People know Mule.
Yeah, of course.
So Mule was 64, Atari, later a Nintendo cartridge. Well, for the longest time, I never realized or knew there was a DOS version of Mule, PC DOS version. Well, there used to be a website, World of Mule, that's kind of long gone, but it's in archive.org, and I dredged through there and found someone mentioned a flux image because it was a bootable, copy-protected floppy. It wasn't a run from DOS game. And I dredged the internet, and I finally found this archived off somewhere, this flux file. And because of that, I was able to recreate the bootable Mule disk for the IBM PC, put it in my PC Junior, and play Mule, just like the 64 or the Atari or whatnot. It's exactly the same game in the same version. Use joysticks, plays the same music as best as it.
Can you do 4-player mode like on the Atari? Oh, on the PC version?
I think it did.
Oh, wow.
So, just as a case there, it wasn't so much rebooting some lost hardware. It was just a case of discovering that a game existed that I couldn't find on Common Archives, and being able to dredge up a flux and with a grease weasel get it back onto a piece of media and actually play it.
Okay, I guess that's it. Thanks, everyone.